Euclid's division lemma. Euclid's division lemma. In this phenomena, lemma means a proven statement, a proved statement which helps to prove other problems. Means, what is lemma? Lemma means a proved statement which helps to prove other problems. Now, Euclid's division lemma means if a, b are positive integers, then there exist q and r such that a is equal to bq plus r, where 0 less than or is equal to r less than b, where b is divisor, a is dividend, q is quotient, r is remainder. So this is Euclid's division lemma. Now, Euclid's division algorithm. Euclid's division algorithm. So algorithm means a well defined steps which help us to give a procedure for solving other problems. So algorithm is a procedure to solve a problems, and lemma means already proved statement which helps to prove other problems. So this is Euclid's division lemma. Now exercise 1.1. Question number first part. Now we have to find HCF. By Euclid's division algorithm. EDA. The number is 135 and 2 to 5 and 2 to 5. So at first we divide it as simple way, means 135 divides 2 to 5. So this is one time 135, we subtract it, 5 0, 12, 12 minus 3, that is 9. Again we divide 90 to 135. 90 to 135. So we continuously divide 90 to 135, that is one time. This goes to 19, that is 5. 13 minus 9, 45. Again we divide 90, that is 2 times, this is 90. So we can see that when we divide 2 to 5 by 135, the remainder is 90. It means that in first part, so 2 to 5, 2 to 5 is written as 135 into 1 plus 90. So we can see that A is equal to BQ plus R. And in this second part, when we divide 135 by 19, it goes one time and the remainder is 45. So we can write 135 as is this first divisor. So first divisor, this is the first divisor, so it becomes second dividend. So second dividend or first divisor 135 is written as 90 into 1. So 90 into 1 plus, that is the remainder 45. So remainder 45. Again we can see in the third section, third part, so here the second divisor becomes the third dividend and the second remainder becomes the third divisor. So 90, we can write 90 as 45 into 2, 45 into 2 plus remainder is 0. So the last divisor is 45. It means this is the HCF. HCF means highest common factor. So HCF of 135 and 225 is 45. Means HCF of 135 and 225 is 45. So if you solve this problem or any problem like this, so there is minimized to be wrong. So there is minimized to be wrong. The chances of correct is increased. So you have to follow these steps. And this is our traditional division, and this is the Euclid's division algorithm. Algorithm means a procedure, means steps. So HCF of 135 and 225 is 45. And the third part is similarly we have to find HCF of 867 and 255. So we divide 867 by 255. 867, so it goes 3 times. 3 5 15, 1 carry, 3 5 15 plus 1 16, 1 carry, 3 2 is 6 plus 1 7. So this is 2, this is 0, this is 1. Again divide 255 by 102, it goes 2 times. So this is 204. Now 5, this is 1, this is 5. Again divide 102 by 51, it goes 2 times. So 102. So we can write first dividend 867 as 255, that is first divisor, into 3 first quotient plus 102, that is the first remainder. Again 255 second dividend. Now 102 second divisor into 2 second quotient plus 51, that is the remainder. Again we can write 102 as 51 into 2 plus remainder is 0. So the last divisor 51. So HCF of 867 and 255 is 51. So this is the algorithm, means procedure of doing problem. So HCF is 51. Next question number second. This is very important question. Question number second. Exercise 1.1. Show that any positive odd integer is of the form of 6q plus 1, 6q plus 3, 6q plus 5. Means we have to show that any odd integers can be written in the form of 6q plus 1, either 6q plus 3, either 6q plus 5. So now we are going to prove it. Let A is any positive integer. A is any positive integer and let B is equal to 6. B is equal to 6. So we can write by Euclid's division lemma, A is equal to 6q plus r, where 0 less than or equal to r less than b. B means 6. B means 6. So we can write r is equal to 0, 1, 2, 3, 4, 5. So now we have to prove that the odd numbers is represented only these three terms, any odd number. So we take one by one r is equal to 0, 1, 2, 3 and put in this form and solve and show the required result. So let means add r is equal to 0, r is equal to 0, then a is equal to 6q plus 0 means 6q. We can write 6 means 2 into 3q, that is 2 into m. So 2 into m, that is the even number, where m is equal to 3q. So which is even number? It means that at r is equal to 0, a, the number is even. So this number is even. Again r is equal to 1. Then a is equal to 6q plus 1. 6q plus 1. We put r is equal to 1 in this form. So we can write 6q is equal to 2 into 3q plus 1. Again we write 2m plus 1, where m is equal to 3q. So we can see that this number is 2m plus 1, which is odd number. So this number is odd, means 6q plus 1 is odd. Again r is equal to 2. Then a is equal to 6q plus 2. We put r is equal to 2 in this equation. So we can take 2 as a common. So 2, that is 3q plus 1, which is, we can write it as 2m. Here m is equal to 3q plus 1. That is 2 is multiplied by m. It means number is even. Again r is equal to 3. Add this number. So a is equal to 6q plus 3. We can write it 2 into 3q plus 2 plus 1. So we can take 2 as a common from these two terms. So 2 is common from here, 3q from here plus 1, and this is the remainder is 1. So we can write it as 2m plus 1, where m is equal to 3q plus 1. So 2m plus 1, which is odd number. Again r is equal to 4. Then a is equal to 6q plus 4. We can take 2 as a common. So 3q plus 2. 3q plus 2. So again that is 2m, where we assume m is equal to 3q plus 2. So multiplied by 2 means number is even. Number is even. Again r is equal to 5. So we put a is equal to 6q plus r is equal to 5 in this number. So this is 5. So we can write is 6q plus 5 as a 4 plus 1. We take 2 is common from these two terms. So 2, that is the 3q plus 2 plus 1. Again we can write as 2. This is m plus 1, where m is equal to 3q plus 2. So this is 2m plus 1, means number is odd. So we can see that 6q plus 5, that is the odd number. 6q plus 3, that is odd number. And 6q plus 1, that is odd number. It means that any positive odd numbers any positive odd numbers can be represented as 6 cube plus 1, 6 cube plus 3 and 6 cube plus 5. So any odd integers, this shows that any odd integers can be represented or written as 6 cube plus 1, 6 cube plus 3 and 6 cube plus 5. Either 6 cube plus 1 or 6 cube plus 3 or 6 cube plus 5 means any odd positive integers is written as 6 cube plus 1, 6 cube plus 3, 6 cube plus 5.